On my earlier talk this morning, I said that I have one key takeaway. I'm going to also reduce this whole 10 minutes, maybe 12 minutes, if I go over time, if I rumble a lot, to one key takeaway, and that is that you walk away from here thinking, this is something I need to look into. I assure you, if you're not applying observability best practices and tooling to how your teams are building software today, you're missing out. So, without further ado, shift left observability and why we cannot live without it. A little bit about me. As I said, I've been working on this space for a long time. Started my career a long time ago. Eventually started a company in the developer tools cross-section with infrastructure space, small startup called Tudum. We wanted to make it easy for developers to deploy their applications. Docker came around. We thought it was a great technology. Worked on that for a couple of years, built tools to make it easy to develop or to deploy your applications as containerized applications. Something that we take for granted today was not that trivial back in 2013, 2014, 2015. Eventually got acquired by Docker, went to work for Docker, building developer tools. And we were building something called Swarm. Some of you may not be familiar with Swarm. Great technology. It was a pain to build and debug. For CI, we would spin up hundreds of nodes. Swarm, sorry, for those of you that may not be familiar with it, was an orchestrator or a scheduler for containers, like Kubernetes, but better. But we would spin up hundreds of nodes and run all these complex tests to it. And then things would fail. I mean, like, what failed? Like, we would have logs from hundreds of nodes, and you'd have to scroll and figure out error, exception? Like, what am I looking for? Why did this error? Like, how do I reproduce this? What was the version that was running at the time? It was a nightmare. We would have engineers on call for CI. And I'm like, we had this problem solved in production. When something failed in production, within minutes, we'd be like, oh, it was this commit, this line, here, this developer, 2 days ago, rollback, now, fixed, done. Wow. And in CI, it's taken us a week to fix that? So then I left Docker. I'm like, you know what? I want to work on developer tools, cross-section with observability. How can I bring all the great tools, live debugging, continuous profiling, logs, metrics, APM, to the development workflow? How can we get visibility into this great black box that everyone is using that is CI/CD? So that brought me to Datadog. I started a company in that space, Undefined Labs, to build visibility. Ultimately landed at Datadog a couple years ago and been working in this space and this product suite that today we call CI Visibility. But before I get started on that, what is shift left generally? Shift left is nothing but the detection of application problems earlier in the software development process. I'll give you a few seconds to read that XKCD. I'm a big XKCD fan, if you couldn't tell. And I'll ask you to raise your hand if you have never shipped a bug to production. Please raise your hand. Exactly. You're all on the hook for it. I knew it. Well, we don't want to be pulling out the flamethrower and burning our hosts, our servers, wherever they may be, because we probably don't even know where they are. But if we were, we still don't want to be doing that, right? So that's what shift left is trying to advocate, is how can we shift things left? And when we mean left, we mean as part of CI/CD, we have this continuous workflow of developers do their builds, their tests, integration tests, and then that ultimately gets through that continuous delivery, continuous deployment. That's the right aspect of the left side of things. So when we say shift left, is can we move some of these things that traditionally have been in production, like observability, but testing and security, earlier in the workflow? Meaning, instead of waiting for things to land in production, can we do them at development? So that is this shift left notion. Now, you may have heard of shift left testing. That is, instead of waiting for our QA teams to have something running in an environment to run their tests, can we run our unit integration, automated, end-to-end synthetics, acceptance tests, entire test suite? Can we run it earlier to be able to detect problems before we ship to production, which ultimately is the goal, right? Similarly, we have the notion of shift left security. Can we run our vulnerability analysis? Can we run our static analysis? Can we find dependencies and issues related to security as our developers are actually running the code and committing these changes to our code base? Why should we have to wait for our containers to be deployed to figure out, hey, the base image has a known vulnerability, let's try and fix that? Could we have done that a few days earlier in development? And today, as I mentioned, I want to talk to you about shift-left observability. And this is not about monitoring the work that our developers do, but again, this is about, are we able to capture, understand, and detect problems before they land in production? But there's a lot more to it than just that, and I'll get to that in a minute. So shift-left observability helps us detect application problems earlier. I'm going to give you a couple examples of this. And these are real-world examples that my team and other teams at Datadog have been able to detect once we brought in this suite of CI visibility tooling into our workflows. The first one, normal commit from a developer, thinks it's not changing or breaking anything. That's a small change to a SQL query. Luckily, we had a set of unit tests that actually, or integration tests rather, sorry, that touched that entry point. And we see that the test that was testing for that behavior went from 187 milliseconds to 774 milliseconds. That is a 4.13 times slower. Now, the test passed. So it went through CI as it normally would have. And I'm willing to bet that 99% of the folks in this room, if this were to happen, you wouldn't have detected it. The test passed. It wasn't a significant increase in timing, so CI didn't take longer. But this specific query was 4 times slower. Now, had we shipped this to production, it would have affected, we would have suffered a negative impact on user experience in our application. That query was 4 times slower now. We were able to detect this because we were applying observability principles to our CI workflows. Another example. Small change happens all the time. You upgrade the library, you change the dependency, how I'm using a XML parser, what have you. All of a sudden, our 237 megabyte container image went up to a 2.6. Wait, what? But that was like a small commit. I didn't change anything. Again, this would most likely have gone unnoticed. Maybe a few weeks later, somebody would be like, hey, what's going on here? And then spent a few hours trying to figure out which commit introduced the regression that led to this. We had our developer notified within 3 seconds of that change happening because we were able to detect and understand the trend of our historical sizes of this container image for this specific application. Now, these are 2 small examples of how you can use CI visibility or observability or shift-left observability, however you want to call this, to detect problems earlier. But as I said, there's a lot more to it, and I've got just a few minutes to cover everything, so I'll go fast. With shift-left observability, we can also reduce the mean time to resolution. That is, something has broken. How long is it going to take me or my team to fix that? And I'll give you a few examples. But increase the mean time between failures. That is, our CI is broken. How long is it going to take me or my team to get it back to working again? And reduce the lead time. That is, I or my team have made a change, a commit. How long is it going to take before that commit actually lands to production, and our customers are able to benefit from that bug fix or new feature? And loads more that I'm going to go run through very quickly. So the first one, reduce mean time to resolution. Say that you have a complex integration test. You have a test that sends a request to some backend service to make sure that the integration is working as expected. With the principles behind shift-left observability, what we do is, what if we apply distributed tracing and APM-like best practices to our testing? So what you're seeing here on the screen, the top span actually represents an integration test. This is not your average HTTP request that I'm looking at distributed trace. This is actually an integration test running in CI, specific execution of that test, tied to a specific commit, a specific developer. The top span, it represents the actual test, and everything underneath are the requests that that test triggered. So these tests failed. Now, as the developer of this test, I'm going to get pinged, and I'm going to take a look at it and see that the reason behind this failure actually is 7 services down. There's a cache server, an authentication server, that actually may have changed their API spec and is throwing an error, and that way not have been well documented. Now, I'm not on the hook to fix that per se, or maybe it's another team. I can go to service catalog and see who owns this service. And I can send them this URL and say, hey, I'm running this test, and your service through this exception to this request, which was well formed. And they have everything at their disposal to fix it, meaning they no longer have to spend a few hours trying to reproduce this test or the state of the system at the time that the test run. So we cut down effectively multiple hours trying to debug and fix this test to just a few minutes. Another one I mentioned was mean time between failures. Talking to a lot of customers, the #1 reason why CI breaks is flakiness. And talking to a lot of customers, the #1 way in which they deal with flakiness is hit that retry button. Come on, it's 2022. Really? We're just going to hit the retry button and hope for the best? Yes, unfortunately. So what if we can actually understand the source of flakiness? What if we can understand, which tends to be tests, not always tests, but tests are probably 80% of the culprits behind flakiness. And flakiness is what for a given, say, commit, a test is showing both passing and failing behavior without a code change. So what we do is very simply, we automatically instrument your test suites, your CI. We understand what's showing flaky behavior. We can tell you, which commit introduced that flakiness. That commit is likely to be the culprit behind the flaky behavior. How flaky is it? Is this a test that's flaking 1 in every 1,000 executions or 1 in every 2? Is this a slow test? Is this a long test? A test that takes 3 minutes to execute, or a test that takes 3 seconds? And the reason why you care about this information is that when you turn this on, you're likely going to find out that you may have 1,000 flaky tests. And then you're going to be overwhelmed. 1,000 flaky, how do I go about fixing this? So what we did is every sprint, our teams come here, they look at the top 10 slower, most flaky tests, and they tackle those. And they tackle the next 10, and they tackle the next 10. And over time, we've been able to reduce our flakiness by huge margins. And now, when our builds fail, it's not due to flakiness, it's usually due to a real issue. So again, shift left observability can help us understand, mitigate, and reduce flakiness. And I mentioned it can also help us reduce lead time. By instrumenting our pipelines and by visualizing our pipelines, by measuring the different stages, the different jobs that our pipelines take between development and production, we can find room for improvement. We can find the bottlenecks. So here we see all of the stages of a pipeline visualized over time. And we see that it changed, I think, on April 9th to April 10th. There's something happened there, and we can see there was a big spike in our Kubernetes deployment. The information is obvious. I can now go back to that day, what changed to that specific pipeline where that increase happened, and figure out what is the culprit behind that. If we were not measuring this data, again, we would not have known to even look. This would have happened for months, and then months upon months. Now the pipeline that used to take 3 minutes is taking 3 hours, and that's the normal state of matters, and developers complain, hey, our pipelines are slow. So how do we fix it? We just need to measure it to be able to fix it. Now there's a lot more things you can do. You can measure queue time, make sure that all the queue time that you have is good queue time, that you have parallelized as much as you can parallelize. You can get your overviews. Test performance, you can set alerts on, as I mentioned, that SQL query test. Make sure that you get notified when tests that are slow are failing, even if the test itself is not failing. You can see common errors to understand that are all of our tests failing for a reason or multiple reasons, and understand which tests are slowest to be able to focus on those. We will be discussing this a little bit longer and more in depth in the open space, architecting for reliability. Happy to talk to anyone that's interested in bringing observability to their development workflows. Just come find me, and I'm happy to discuss. You can also see a demo. We have one of our demo stands will be doing a demo of CI visibility. Thank you so much for your time. It's been a pleasure.